I'm Zach, and my project is Insight, tension-based haptic feedback to improve mobility navigation for blind people. It's creating a navigational aid to improve navigation for blind people. So globally, 36 million people across the world are blind, and being blind has a lot of issues with performing activities of daily living, like navigation. And so as a result, many blind people use navigational assistance. The primary one is the white cane, which is a cane which usually has white on the top, then red, and then a white tip. It's kind of the universal symbol for blindness. And it also has a lot of key characteristics that make it a very good navigational aid. It's inexpensive, so it's easy for people to get and replace if it breaks. It's intuitive. When you pick up a white cane, you know how it works. It goes around and it feels things on the ground for you, so you don't have to touch them yourselves. And it's also reliable. It doesn't have any moving parts, so there's not really anything that can go wrong with it. There's been a lot of research into creating new navigational aids using new technologies like computers and robots to improve mobility and navigation for people who are blind. However, none of them have really captured these aspects. Another aspect that they haven't really captured is depth perception, and that's where Insight comes in. So Insight is a tension-based system, so it has 3 wires that connect at a single handle, and as the user moves their hand around, we can provide forces on the user's hand, so that way it will feel like you're reaching out and touching a virtual wall, basically. You'll feel a normal force from the wall pushing back at you. So it is a 2D LiDAR mounted to some surface on the user, and then this harness that they wear, which contains the motors and wires and spools. And we house all the electrical systems in a backpack, along with some of the motor housings. And this is what the software pipeline looks like. First, we take in 2D data from the LiDAR, reconstruct that into a map of the surroundings. We locate the user's hand in the virtual space that is where the handle is. And then we are able to figure out what types of forces the user's hand should be feeling at that moment. So if they're touching a wall, they should be feeling a little bit of a force from the wall. If they're a little bit past the wall, that kind of represents pushing on the wall, so they should feel a force back from the wall. Insight started out as a class project in a class called Human-Robot Interaction. Right now the team is me, Alex Bakovitz, and Jonathan Duffy, where Alex is a mechie and Jonathan is an electrical engineer. Originally we had a 4th member, but he's since graduated. I'm being advised by Henny Admoni, who is a professor in the Robotics Institute, and her PhD student, Benjamin Newman. This is what I'll be doing over the rest of this semester and in the upcoming semester. So there's a big problem with Insight right now in that it's not very reliable and not very easy to use. The perception data that we're getting back from the 2D LiDAR is pretty limited because it only senses a single plane. So we're looking into new perception systems. For example, the Z stereo camera, which provides depth of field for the entire area in front of you. So that way we can get good 3D resolution and be able to detect much finer obstacles, like, for example, the shape of a door frame. We're also looking into better kinematics so that it's more understandable what the user's hand is experiencing. This will include both improvements to the motors and also improvements to the current kinematic system, involving making sure that the user actually feels an approximation of what they would feel if they were touching an actual wall. Following this, we plan to perform a couple of user studies. Our first user study will be a pilot study on people who are sighted. They will be giving qualitative feedback on the system, so that way we can verify that the system actually works and doesn't just not work at all. Following this, we'll be having our primary study, which will use blind and visually impaired people performing standard navigational tasks. We will then collect quantitative data like error of positioning and number of wrong turns, for example, in a navigational task, to verify the effectiveness of Insight as a platform for navigation. Thank you. Any questions?